to our Electrical Principles and Practice NCV Level 2 lesson for today. My name is Mr. Sanjeevi, and today I'm going to be teaching you about measuring and testing instruments. Let's look at our objectives, our learning outcomes. We're going to be looking at analog and digital measuring instruments. Our key objective, however, is to differentiate between digital and analog, to identify, use and connect different measuring instruments, and to extend the range of an ammeter and a voltmeter. Previous knowledge that you should have in place is electrical components, the difference between AC and DC, electrical symbols, series and parallel circuits. All this knowledge you should have in place. Very briefly, let me just remind you one more time about this yellow star that you see on your screen. Students, please take note that all these yellow stars indicate important aspects that you need to know and to learn for exam purposes. Make sure you take careful consideration to whatever you see appearing on the screen wherever you see a yellow star. On the slide, you will see on the top there is an analog meter, and at the bottom there is a digital meter. How do I tell the difference? An analog meter has a moving pointer that deflects, indicating the values that it represents. Whereas a digital meter has an LCD screen which has digits that appear on it. Remember, LCD stands for liquid crystal display. The first of our instruments that we're going to be looking at today is the multimeter. A multimeter is a device that is used to measure different values and that combines several measurement functions in one instrument. All multimeters can measure voltage, current and resistance. However, some of them can measure additional values for example, temperature and capacitance. On your screen you will see two types of multimeters. The one on your left is a digital instrument, the one on your right is an analog. Students, you must be able to tell the difference between the two, as we've indicated in the previous slides. What are the advantages of digital multimeters? They are more accurate. Digital multimeters have no moving parts. They are easier to read. They are cheaper. Parallax errors are eliminated. Obviously, you're asking, what's this parallax error? Because it seems like such a big, difficult word. Let's go and see what parallax errors are. The error of parallax is a difference in the apparent position of an object viewed along two different lines of sight. So in the picture that you see here, that view of sight right from the top is the correct way to look at an analog instrument. But if you're looking at it as indicated by these pictures of sight from two different angles, then you are never going to take a correct reading, as indicated at the bottom. If you're looking at it from an angle, you're going to get an incorrect reading, and if you're looking at it from that angle, you're also going to get an incorrect reading. Please make sure that you look at it directly from above. Let's look at this analog meter on our right hand side, and you will notice that we are looking at it from the side and not from the top. Immediately when you're looking at it incorrectly, you will notice there's a shadow that appears under this needle. And if you see this shadow, that means you are looking at it incorrectly. Whenever you are looking at it correctly, you will not see this shadow. Make sure that you are looking at it correctly. This slide shows you a digital multimeter with the selector switch set on voltage DC. Now, there are many different functions on this multimeter, and I need to know how to use it if I am a good electrician. So I need to familiarize myself with all the different functions that I need to choose to measure different values. And to do that, I need to familiarize myself with all the symbols that appears on this particular instrument. Let's go and see what symbols are represented here and what they stand for. The first symbol that we come across is the home symbol. And you can see it on this multimeter. When I set the selector switch to that symbol, it means I am going to test resistance. And so if I choose this symbol, it means I'm choosing the beeper or the buzzer scale, and I will go and choose that scale to test for continuity. And so you can see the rest of the symbols that appear on this multimeter. There is amps DC, amps AC, frequency, which is represented by HZ. There's a symbol for capacitance, the symbol for the diode. We have right on top voltage DC, and above it voltage AC. Students, please take note. If you are not familiar with these symbols and what they stand for, you will never know how to use this instrument correctly. Therefore, it's your prerogative to ensure that you learn all these symbols, that you know them, so that when you are using this instrument, you use it correctly. If you don't know the correct selector switch setting that you need to do the test that you have to undertake, you will make a mistake and you will take incorrect readings. In fact, you could hurt yourself very badly as well. We are going to do 3 tests, or I'm going to teach you how to do 3 tests, and the first one is how to test for current. When you are testing for current, go back to your circuit and ensure that the circuit is de-energized. In other words, switch off that circuit. Then you will disconnect, cut or unsolder that circuit, creating a place where the meter probes can be inserted as indicated in the drawing. Okay? Just like how you see in this drawing, we have broken the circuit, we have brought the test probes in. Then we need to go to our selector switch and select current or amps, AC or DC as desired. Plug the black test lead or the black probe into the common port, into the common terminal, and the red test lead into the 10 amp terminal. Connect the probe tips into your circuit in series. Choose the correct scale, as I've said before, and now make sure the power is switched back on, because you cannot test for current if the circuit is de-energized. Make sure the power is switched back on. View the reading and make sure you read the unit that's given here correctly. This reading is 25.3 amperes. Right? Students, please take note as well. Whenever we test for current in industry, we do not use this method. We do not test for current like this, where we go and break the circuit. This method is only used in laboratories or when we are testing currents of very small values. Right? Don't go and use this method in industry. The second test that we're going to do is a voltage test. When we test for voltage, make sure that the red lead is put onto the voltage terminal and the black lead is put onto the common terminal, right? The common port. Choose the correct scale. You can either be testing for voltage AC or for voltage DC. And then touch the probe tips across whatever you are testing. Maybe it's a battery, maybe it's a resistor, but whenever you're doing this test, remember you are going to be doing a voltage test in parallel. Check your readings that appears on the screen of your multimeter, and also make sure you look to determine the unit that is being used. Whenever you are testing for voltage, ensure the circuit is energized. You cannot test for voltage on a circuit that is switched off. Our third test is a test for resistance. How do you test for resistance? Students, let me stress this point. Whenever you are doing a resistance test, always make sure that the circuit is de-energized. Always make sure that the circuit is de-energized. You can never do a resistance test on a live circuit. Plug the black test lead onto the common port and plug the red test lead onto the Ohms terminal. Remember, whenever we're testing for voltage, we are testing whenever we are testing for resistance, we are testing in parallel. Please, students, ensure that you do that. Test for resistance, test in parallel. When you are taking your readings, make sure you note the unit of measure. If you took this reading and if you told me this reading was 25 ohms, 25,01 ohms, then you would have taken an inaccurate reading because the unit here says kilo ohms. The correct reading should have read 25,01 kilo ohms. Make sure that you always look at the units for whatever you are measuring. Now we're coming to moving iron and moving coil instruments. Whenever you are using these particular devices, an analog measuring instrument must have an operating or deflecting device, a damping device, and a controlling device. Let's take a note of a few things from the table that we have indicated on our slide. When we are using moving iron instruments, our measurement is done in AC and DC. However, our moving coil instrument the measurement is only in DC. In moving iron instruments, our scale is nonlinear. In moving coil instruments, we use a linear scale. In moving iron instruments, they are controlled by spring or gravity, whereas moving coil instruments are controlled by springs. And moving iron instruments are damped using air, whereas moving coil instruments, damping takes place by the use of eddy currents. In this two drawings that you see appearing on your screen, you will notice that in moving iron instruments, there are two types. There is the attraction type and the repulsion type. However, in moving coil instruments, we have the permanent magnetic type and the dynamometer type. In the slide, you will see we have different ways of connecting up meters. In the first drawing, you will see an ammeter and a voltmeter connected up in a circuit. Students, please take note, this is an ammeter and a voltmeter connected up in the circuit. Sometimes the examiner could ask you just to draw the ammeter only, or just draw the voltmeter only. If they told you draw the ammeter only, don't draw this part here. Leave out this voltage part of that circuit. But if they did tell you to draw the voltmeter in a circuit, then remove the A in the circle. Don't have anything there, but draw this part of it. You will also notice that our ohm meter is connected up in parallel, as indicated in this drawing, and so too is our frequency meter. And students, you will also come across a power factor meter. The frequency meter and the power factor meter drawings are identical. The difference between the two of them is that the frequency meter has HZ in the circle, and the power factor meter, we will remove the HZ and just write PF. In the last drawing that appears on your screen, you will see we have a wattmeter, and a wattmeter has two coils. It has a series coil, which is the current coil, and it has a parallel coil, which is our voltage coil. Whenever you're drawing this wattmeter, use this type of drawing to indicate how a wattmeter is connected. Now, I've told you before that whenever we measure current in industry, we do not use a a multimeter to measure current. The correct device that we use to measure current is called a clamp meter. Another name for clamp meter is tongue tester. How do you use a clamp meter or a tongue tester? Select the correct scale, and that is amps, AC or DC, depending on what you are testing. Place the clamp around the phase conductor only. Students, let me emphasize that point. This is the clamp. The clamp is the red part that you see on the top. Place the clamp around the phase conductor only. There are two drawings that you see indicated on the slide. In the first drawing, you see that we don't have the clamp around the phase conductor only. We've got the clamp around the phase conductor and the neutral. That is incorrect. You should remove the neutral wire and only put the clamp around one conductor. In the second drawing, you will notice that we have three phases that are coming to this circuit breaker. Whenever you are testing those three phases, the red phase, the yellow phase, and the blue phase, make sure you test them one phase at a time. You cannot put two conductors or three conductors around or inside this clamp. Only one conductor at a time. Whenever you are testing for current with this instrument, make sure that the circuit is energized. In other words, the power is connected. The last instrument that we're going to be looking at for today is an insulation resistance tester, or MEGA. Now, on your left hand side, you will notice that we have an analog MEGA, and in the center we have a digital MEGA. However, I've also included a picture of a multimeter. Now, a multimeter looks very similar to this digital MEGA. And that's the reason why I've included it here, because I want you to be able to easily identify which is the correct instrument that we will use whenever we are doing a MEGA test. On the MEGA itself, you will see that it has three voltage values, three scales that indicate voltage, and it starts at 250, it goes to 500, and it goes to 1000 volts. But what you will see there is that all of them are indicated in red. Whenever those voltages are indicated on a MEGA, they will always appear in red. Always appear in red. Even in this analog MEGA, here you can see it, 250, 500, 1000, and they appear in red. Your MEGA will also tell you, like indicated right at the top of this instrument, insulation tester, and right at the bottom here as well, it says insulation continuity meter. Right? So you must be able to identify the device that you are using. Otherwise, you could use the wrong device and you could end up hurting yourself very badly or taking incorrect readings. How do you use an insulation resistance tester, or MEGA? As I've said before, a MEGA is a very dangerous instrument. It can shock you. A MEGA test is done to determine if the insulation of a component, conductor, or equipment is damaged. When doing an insulation resistance test, always use double the rated voltage. If the equipment is rated at 230 volts, like for example, your stove or your kettle, make sure you choose the 500 volt scale to do the test. Never do a MEGA test, and let me say that again, never do a MEGA test on a live circuit or an energized circuit. Make sure the circuit is de-energized before you do a MEGA test. Whenever you are doing a MEGA test, remove all the bulbs, unplug electronic devices, and disconnect capacitors before beginning the test. Your acceptable readings will always be 1 megaohm and above. Precautions when using measuring instruments. Never use an ohm meter on a live circuit. never connect an ammeter in parallel, never connect a voltmeter in series. Always choose the correct scale. Make sure you choose the correct instrument for the application, and do not use test probes that are damaged. Now students, we want to look briefly at how we extend the range of an ammeter. How do we extend the range of an ammeter? The first thing you're probably going to ask me is, why do we extend the range of ammeters? We extend the range of ammeters so that we can take higher values of readings than we normally do. So if we're going to read a high value of current, then I need to extend that range of that ammeter. How do I do that? How do I extend the range of an ammeter? Let's go and look at it very briefly and see what we want to do. We will take a shunt resistor and we will connect it up in parallel to that ammeter. Let me say that one more time. We will take a shunt resistor and we will connect it up in parallel to the ammeter. When we do that, we now have a parallel circuit. And because we have a parallel circuit, the current that travels in the circuit is very important for us to take note of it. IT is equal to ISH plus IM. IT is traveling down this path, and when it comes to this junction, it splits. Some of it will come down as ISH, some of it will travel down this path as IM. And you can see here on this particular slide, I have indicated IT is equal to ISH plus IM. Okay? Our main formula, however, is RSH is equal to IM times RM divided by ISH. And you will find this formula. You will find this formula on your exam formula sheet. Let's go and see a typical question that comes up in your exam. Okay, so here's our typical question. A moving coil instrument with a resistance of 5 ohms gives a full scale deflection of 10 milliamperes. Calculate the shunt resistance required to use the instrument as an ammeter for a 2 amp current flow. So this is a question that you're probably going to come across in your exams. The first thing we want to do is to write down all the information that is given. I am given 2 amp current flow. Remember, I have 10 milliamperes, which is traveling through the instrument. There's the instrument here, and there's a current that travels through it, so that becomes the current of my meter, IM. But I have also been told that there is a 2 amp current flow that travels through the circuit. I'm going to label this 2 amp current flow my IT. So I have IT, I also have IM. Then they told me that this instrument has a resistance of 5 ohms. So I'm going to call that RM, the resistance of the meter or the instrument. All right, so here's it here. IT is 2 amps, RM is 5 ohms, IM is 10 milliamperes. IM is a current traveling through that meter. Here's my formula. RSH is equal to IM times RM divided by ISH. Let's go and see if I have everything that I need to do this calculation. Do I have IM? Yes, I do. Do I have RM? Yes, I do. Do I have ISH? No. I don't have ISH. So I need to determine what's ISH. And I'm going to use this formula here. ISH is equal to IT minus IM. Where did I get that formula? I got it from the previous table. IT is equal to ISH plus IM. If I make ISH the subject of this formula, ISH becomes IT minus IM, as indicated here. I know what's the value of IT. It's 2. It's given to me. And I know what's the value of IM, 10 milliamperes. But wait, why did I put 10 divided by 1000? The SI unit for current is not milliamperes. The SI unit for current is not milliamperes. I need to bring it back to the base unit. The base unit is amperes. To convert milliamperes to amperes, I need to divide by 1000. And therefore you see 10 divided by 1000. And my answer is 1,99. Now that I've worked out the value for ISH, I can bring my main formula back in. And I've said RSH is equal to IM times RM divided by ISH. Let's put in all our values. IM is 10. Remember, I need to convert it from milliamperes to amperes, and therefore I will divide by 1000. I have the value for RM, which is 5, and I have calculated ISH, which is 1,99. And my answer is going to be 0,025. And that's basically what the question is going to look like that will come out in your exam. The other question that you're going to come across is, how do you extend the range of a voltmeter? To do this, we bring a series resistor and we connect it up in series to the instrument. IT is equal to IM, and that is very important to identify in the circuit, because IT is the total current and IM is the current that travels through the meter. Students, in a series circuit, current remains constant. So the current throughout the circuit is always going to be the same. Let's go and look at a typical example. A moving coil instrument with a resistance of 5 ohms gives a full scale deflection of 10 milliamperes. Calculate the series resistance required to use the instrument as a voltmeter up to 12 volts. What's given? VT is given as 12, RM is given as 5, IM is given as 10. There's it here. Let's put it into, and don't forget IT is IM. Let's put it into our formula. Remember, we said VT, RSC is equal to VT divided by IT minus RM. I know what's VT, 12. I know what's IT. Remember, I said this is a series circuit, therefore IT and IM is the same, which I will use as 10 divided by 1000 minus 5, and I'm going to get an answer of 1195. Students, in the exam, this is how this question appears. A moving coil instrument with a resistance of 5 ohms gives a full scale deflection of 10 milliamperes. Calculate the shunt resistance, calculate the series resistance. I want to highlight, many students, when they are calculating the series resistance, they take this as their current value for calculating RSC, and they don't use this. Don't make that mistake. Always use this value for the second part of your question as your IT. In conclusion, in this lesson, we studied measuring instruments. You, the student, are now able to easily identify the differences between an analog and a digital measuring instrument. You should be able to identify, use, and connect different measuring instruments. You should be able to extend the range of an ammeter and a voltmeter. Thank you. Make sure you keep safe. Practice your social distancing. Till we meet again.